Hello and welcome to the APECE Chemistry Chapter 15 Complex Ions problem set. Let's take a look at problem number 13. In problem 13, you were asked to consider chromium-3 and how it formed complexes of many types, and you were asked to give the formula and charge for the following, and it describes in words what sort of things would be bonding with the chromium-3. Two oxalate ions, and they give you the formula C2O4, 2 minus, and two water molecules. So the complex ion with chromium, two oxalate ions, and two waters would look like this and have a charge of -1. In part B, you're forming a complex ion with the chromium-3 ion and 5 ammonia molecules and a sulfate ion. That would be Cr parentheses NH3 close parentheses 5 and then SO4 with a +1 charge. And finally, chromium-3 with 1 ethylene diamine molecule, 2 ammonia molecules, and 2 iodide ions would become Cr, and ethylene diamine is abbreviated En. 2 NH3s and 2 I minuses come out to a total of +1 charge. Let's take a look at problem 5, A and C. You're asked to find the coordination number, and you're given a group of ligands connected to the central metal cation. Molybdenum connected with CnS2 and En2. The coordination number is 6 here. Remember, ethylene diamine is a bidentate ligand. And for C, Ag, NH32, two things connected to it. 2 is the coordination number. Let's take a look at problem 13. Problem 13, you're asked to find what is the mass percent in a cobalt-containing complex ion with 3 ethylene diamines, and you are told that ethylene diamine has the formula H2NCH2 CH2NH2. So there's a total of 6 nitrogen atoms in the whole complex ion of cobalt combined with 3 ethylene diamines. And 6 times 14.01, the molar mass of nitrogen is 84.06. When you do the whole molar mass of this whole compounded complex ion, it's 239.24. Divide the 84.06 by the 239.24, and multiply by 100, you'll find it's 35.14% nitrogen. Take a look at problem 19. Problem 19, you're told that you're dealing with a different ligand than what you're used to. It is a bidentate ligand, abbreviated DEC, D-E-C-H, and you're asked to sketch a palladium-containing complex ion with a DEC and then two water molecules. And it should look something like this, where you're getting both connections to the electron-containing nitrogens to the palladium on one side. Take a look at problem 25. In problem 25, you're asked to give the electron configuration for several different central metal cations, Ti3+, Cr2+, Ru4+, Pd2+, and MO3+, and you have to pick out the electrons that would leave. For most of these, you're going to lose the s electrons first. So you'll see here there's a 3p6, 3d1. There's no 4s. Those are 2 of the 3 electrons that were lost here. And then you'll see here a 4s missing. This one you'll see 5s is missing. Right here you'll see 5s is missing. And again you'll see here is 5s is missing. In problem 27, you're asked to write an orbital diagram for the outer edge of these substances. Since the s electrons are missing, you're going to be showing the d orbital on all of them, whether it's 3d or 4d. And then you can abbreviate the things before. So titanium 3+ is argon, then 1 more electron. Chromium 2+ is argon, then 4 electrons. Remember Hund's rule, these will all separate before pairing up. Ru4+ is krypton, then 4 electrons. Pd2+ is krypton, and then 8 electrons. And then molybdenum 3+ is krypton, and then 3 electrons. Let's take a look at problem 33. In problem 33, you're told that chromium-containing complex ion with cyanide in it is less paramagnetic than chromium-containing ion with water in it, and has to explain why. Cyanide is a large splitting or low spin ligand, so here you've got your D outside shell, and it's a large splitting, so the electrons will tend not to go into these higher ones, and they'll have one paired up together. But water is not as large of a splitting thing, as low of a spin thing, and so you'll get a small splitting energy. And with a small splitting energy, the electron that was in this position right here in the cyanide-containing compound from the central metal cation will actually get to advance into the higher D sublevel shell in the water-containing chromium-containing complex ion. So overall, having more unpaired electrons means more paramagnetic, which is why the water-containing substance with chromium is a more paramagnetic one.